Module 1, Operations with Integers. This is section 1.3, Exponents, Square Roots, and Order of Operations. We use exponential notation to show repeated multiplication. So if you want to multiply 3 by itself 5 times, instead of writing out 3 times 3 times 3 times 3 times 3, you can say 3 and then use a small superscript, a small floating number up to the right of a 5. That's an exponent. So instead of writing out 3 5 times, I can say 3 raised to the 5th power. Power is another way to refer to an exponent. Your base can be many different types of numbers. It could be a whole number, it could be a negative number, it could be a fraction, it can have a decimal in it. But your exponent will be a whole sign number, also known as an integer. If you have a base of a 3 and an exponent of a 2, we read it as 3 to the 2nd power. You can also say 3 squared. 3 to the 3rd power is when you have a base of a 3 and a power of a 3, and you could also say 3 cubed. However, once your exponent is larger than a 3, we normally just say whatever your base is and raise to the power that's given in the exponent. So 3 with an exponent of a 4 would just be 3 to the 4th power. If you want to evaluate it without a calculator, all we need to do is take my base and write it however many times is listed in the exponent, and then complete the multiplication. So 9 squared is 9 times 9, which is 81. 4 to the 5th power would take 5 4s and multiply them all together. Without a calculator, it can be time consuming. 4 times 4 is 16. Times another 4 would be 64. 64 times 4 will be 256. And then finally 256 times 4 will be 1024. If you have an expression where one number has an exponent and the other doesn't, you need to take care of the exponents first. So I can't do anything with that 5 until I figure out what 3 squared is. Well, I know that 3 squared is 3 times 3, which is 9. So 5 times 9 is 45. You never multiply a number without an exponent times a number with an exponent. If you want to undo the exponent, then you would take a root. So if you want to undo a square, say 3 squared is equal to 9, and you want to go back to this form, I would say, what is the square root of 9? What number times itself is 9? Well, 3 is, because I would say 3 times 3 to get 9. So the square root of 9 is 3. 12 times 12 is 144, so the square root of 144 is 12. The square root of 25 is 5, since 5 times 5 is 25. Square root of 121 would have to be 11, since 11 times 11 is 121. And of course 0 times 0 is 0. So the square root of 0 would also have to be 0. I would recommend memorizing your square roots up to 15 squared. We often see exponents when you're dealing with order of operations. There's a variety of ways to remember what the order of operations is, but probably the most popular is to use PEMDAS. Parentheses, exponents. You'll do multiplication and division from left to right, and then addition and subtraction from left to right. Not all the multiplication and then all the division, but as they appear. So if I have 2 times 4 minus 3 divided by another 3, well, I don't have any parentheses and I don't have any exponents, but I have quite a bit of multiplication and division. I need to do that from left to right. I have 2 times 4. That's 8. 3 divided by 3, that's a 1. There's a subtraction symbol in between. All my multiplication and division is done. Now I'll do addition and subtraction from left to right. I only have the 1, and so this simplified is 7. If you don't follow the order of operations, you'll get a different number. This one has almost everything. It has parentheses. It has exponents. It has 2 sets of parentheses. It has multiplication and division. It has addition and subtraction. When you have parentheses, you always start with parentheses. If you have 2 sets of parentheses like we do here, you start with the one on the most inner part of the parentheses. So whatever's on the inside. So 10 divided by 2, it's the only thing in there, that's 5. And then you rewrite everything else. Now I have another set of brackets. Brackets and parentheses mean the same thing. In here I have exponents, so I'll need to start with that. We already know that 3 squared is 9. I still need to finish my brackets and say 9 minus 5, which is 4. Parentheses are done. Now to take care of my exponents. I have 4 cubed, which is 4 times 4 times 4. 4 cubed is 64. So now I have 64 plus 4 minus 7 times 3. Multiplication and division from left to right. Well, I only have one multiplication right here, and negative 7 times a 3, which is negative 21. In this case, there would just be a subtraction. Now I only have addition and subtraction. You go from left to right. 64 plus 4 is 68. 68 minus 21 means that this expression is equal to 47. That's a long one. When you have fractions, it can be a little deceiving because we know that the fraction bar is a division bar. But when you see expressions that look like this, you want to think about them as 2 separate problems. You want to do all the stuff on the top and then do all the things on the bottom. It's almost like you have 2 different PEMDAS problems. Let's take care of the top first. Well, I have no parentheses up top. I have no exponents, so I have to do multiplication and division from left to right. 9 divided by 3 is 3. Just rewrite everything else. Now addition and subtraction. Well, I only have the addition, and 3 plus 6 plus 3 is 9. I'm down to one number on the top, so now I'll worry about the bottom. No parentheses, but I do have exponents. 3 squared is 9. So this turns into 9 over 9. Now that I only have one single number on the top and the bottom, nothing else needs to be simplified. Now I want to do that division for the fraction. And this is equal to 1. When you have fractions, think as your top part, the numerator, as one PEMDAS problem, and your denominator as another. When they're all simplified and they can't be simplified anymore, that's when you divide. Back to exponents. 2 applications of exponents is finding the area of the square and Pythagorean theorem. Let's start with area. You have a square, then you have a 4-sided figure where all the sides are the same length. So it's very easy to find the area, which is length times width, or in the case of a square where they're all the same, I can say side squared. So if I have a square with the length of one of the sides is a 4, they're all 4. And 4 squared is 16 because 4 times 4 is 16. The Pythagorean theorem has to do with right triangles, triangles that have a 90-degree angle in them. The sides that make up the 90-degree angle are called legs. The side across from it is called the hypotenuse, and the hypotenuse is the longest side. Now it doesn't matter whose leg and whose other leg. Those can change, but the hypotenuse is always the side across from the 90-degree angle. The sum of the legs squared is equal to whatever the hypotenuse is squared. So if you know any two sides of your triangle, a right triangle, you can find the third. If you want to work backwards to find a leg, you can rewrite your theorem. Here I have a right angle right here, and I have a leg of 22 and another leg of 48. Which one's the leg and which one's the other leg doesn't matter. Now the original formula has the hypotenuse squared, and then it's leg squared plus other leg squared. But we know we don't really want the hypotenuse squared. We only want to know just the hypotenuse. So I'll take the square root. And the square root of something squared always leaves you with the base. So the square root of the hypotenuse squared is just the hypotenuse. But since I have this addition symbol right here, I can't just say leg plus other leg. I'm going to need to simplify this expression. The square root symbol works like a parenthesis. So I'm going to need to work from inside of the square root symbol and work my way out. 22 squared is 484. 48 squared is 2,304. Now we'll add those together and I get 2788. I'll use my calculator to help me find the square root of this by hitting in the number and then hitting the square root key. And the hypotenuse is about 52 meters long. Here's another. In this case, I know the hypotenuse, but I don't know this leg. So it's hypotenuse squared equal to a leg squared plus my other leg squared. Here I know my hypotenuse. It's a 9. And I know one of the legs, but I don't know the other one. So I can either solve this expression or use the rewrite that we have here. Here's my hypotenuse, and here's one of the legs. 9 squared is 81, and 3 squared is 9. Now subtract, and 81 minus 9 is 72. Use your calculator, hit 72, and then the square root symbol, and you'll see that that leg is about 8.5 yards long.